All right, my name is Yoel Spots. I'm a senior engineer, whatever you want to call it, at TST based here in Atlanta. And what I want to talk to you today is about the JDK tools, what I like to call the secret weapons of the JVM. About me, you don't really need to know all that much. What I find especially amusing is in a lot of these presentations is where somebody puts a nice little picture of themselves right over here, because it's not as if you can see them right in front of you. First of all, I want to think, oh, so there's a nice little picture of me. I want to start off by acknowledging the various resources that helped me research this topic. There are a couple of great presentations, actually one fantastic presentation. I'm probably going to butcher the name, so I'll just let you read it. But he's a developer at Oracle, and he got some inside knowledge that's not documented anywhere, and I found that presentation to be especially helpful. Marcus Hertz is also an employee of Oracle, has a very nice blog on some of the internals of the JDK, the JVM, and some of the Oracle resources. Now, the Oracle resources, I would say some of the documentation is a little bit long in the tooth at this point, and you read through it and you see that there's some legacy stuff in there, some gotchas that are not quite documented. Overall, the documentation is fairly good, but there were times when I had to spend a little bit of time Googling and trying to figure out why what I expected to happen didn't quite happen. So let's cover the agenda, and I'll just say at the outset, please feel free, even though we got started a little bit late, please feel free, if you've got any questions, interrupt me at any time. I'll try to recognize you if I see your hand up. I might finish a thought, but please feel free to ask me any questions, or if you want to wait till the end, I'll be more than happy to stay a little bit afterwards to answer any questions you might have. So going through the agenda, pretty simple agenda. I wanted to first talk about why it is that we want to take a look at these JDK tools. What is that we're hoping to get? What information are we hoping to get from them? I want to narrow the scope of our discussion, because we could spend a tremendous amount of time if we were to look at all the JDK tools. So I want to narrow the scope, discuss what exactly we're going to be looking at. An important topic, which at first glance might not be related, or you may think is not related to some of these tools, but in reality it plays a very important part, is connecting to the JVM. As it turns out, and this is something that I was surprised by, there are a number of entry points into the JVM, well beyond what I would have expected. And then we'll take a look at some of the actual tools, and depending on the time that we've got at the end, we'll try to do some demo. Might shorten it depending on the time structure. First question we want to take a look at is why? What is the purpose? What are we hoping to accomplish? This is what the knowledge that I'm hoping to impart to you at the end of the session. So first thing is, I think you'll find that a lot of these tools are quite helpful. And you'll find them even in your day-to-day. I know that I have, in some of the work that I've done, I've found some of these tools to be extremely helpful in terms of troubleshooting, in terms of monitoring, and some of the other aspects of production-level code. So that's the very first thing. Second thing is, even if we never use these tools, I think you'll see that an understanding of how these tools work and what they accomplish will give you a deeper understanding of the JVM. When you're going through the process of developing code, even putting in production, it's very easy to just look at your code as a series of bytecodes and to not think past the JVM in terms of bytecodes and the execution of those bytecodes. But examining these tools gives you a deeper appreciation and understanding for the JVM lifecycle and some of the underpinnings for what the JVM is doing behind the scenes. And so some of the mechanics, some of the entry points into the JVM, and it'll give you a greater appreciation for how your code is running on the JVM, and that will give you a better understanding for troubleshooting your code, even if you're not going to use the specific tools that we're going to look at. In addition to that, as I'll mention in the next slide, we're going to be taking a look at primarily command line utilities. And even though you may never use these specific command line utilities, but it'll give you a greater appreciation for how some of the UI tools like Visual VM, JConsole, Java Mission Control, how they operate under the scenes, and they'll give you a better understanding for how better to utilize those tools when you troubleshoot your code. And finally, a lot of the discussions, certainly at this conference or when you are developing your own code, you have tunnel vision into the specific language that you're using. We all used to use only Java. Now we know that there's so many other languages on the JVM. These tools that we'll go through and that we'll talk about are helpful for whatever code, whatever language you're using to write your code. Happens to be where I work right now. We're a Scala shop, so it doesn't matter. It could be JRuby, it could be Groovy, whatever it is that you're working on. These tools are helpful because they work at the JVM level. They work at the bytecode level. So this is beyond the point of where you're compiling or whatever it might be. This is at a lower level. And so these tools, I think you'll find, are helpful for whatever language you're using on the JVM. So in order to narrow the scope of what we're going to be taking a look at, I just want to, like I mentioned, there are a whole host of tools that are made available by the JVM, by the JDK. Number one, there's only so much that we can cover in the time that we have allotted. And number two, we're going to take a look at the tools which are closer to the bare metal, so to speak, the command line utilities. There are very nice UI utilities that the JDK provides for monitoring, troubleshooting, and other type of things. We're going to be focusing mainly on the command line utilities. And as I mentioned, this will give us an appreciation for how the UI utilities work. To give an analogy, if you will, 10 years ago when you give this analogy, you start talking about assembly code. So if you're programming in C, helps you to give an understanding for how assembly code works, right? In order to better appreciate how to code in C, so if you have an understanding of how assembly works, so it makes you a better C programmer. Today, I don't think that analogy stands up anymore. Today, we'd say that if you're programming in Java or in any of the other languages, an appreciation for how coding in C will give you a better appreciation for Java. So the higher level of abstraction, so a lot of times, so certainly there's an advantage there because it hides some of the lower levels, but there are times when you really do need to understand the lower levels. And so some of these tools really are operating at a much lower level of abstraction. And so they'll give you an appreciation for how it is at the higher level of abstraction. So again, going back to our analogy, we may never use memory management when we're programming in Java. Hopefully we won't. I know I never want to. But at least understanding how memory management works in C gives you an understanding, gives you an appreciation for what Java is doing behind the scenes. So a lot of these command line utilities that we'll go through and we'll discuss will give you a better appreciation for how things are working at the higher abstraction levels, some of the UI, and even your running code give you a better appreciation for what the JVM is doing. In addition to that, we're going to narrow the scope to some of the monitoring and troubleshooting tools. As we'll see, there are a number of tools, even command line utilities that are provided, but we're going to try to focus on monitoring and troubleshooting. And like I said, we'll try to go through some examples. Finally, I tried to focus on utilities that required little to no setup. So I didn't want to include anything that required any coding or anything that required you to run agents along with your Java program, or even I wanted to avoid command line parameters or JVM parameters as much as possible. So let's just give you an idea for what it is that we're going to be taking a look at. So this right here is a directory listing of JDK home bin. I don't know how many of you have actually taken a look at what's in here, but the first time I saw this, I was rather surprised by the number of binaries that are actually here. And certainly the first time I took a look at this, I kind of scratched my head and I said, what are these things? Right? I know, and we'll go through some of these, some of them look quite familiar, Java C, Java, After that, it can get a little bit murky. But this is the first thing that really surprised me, is taking a look at all of these different binaries that are available, or that are made available by the JDK. And it's actually surprising to me how unfamiliar or unwell known most of these things are to most people. I may be just looking at myself, but again, most of these things, even before I started researching this, were fairly unfamiliar to me. So the Oracle documentation, take a look at their discussion of the tools and the binaries they provide. They group these binaries up into separate categories. And I found it very interesting taking a look at these different categories, and again, looking at to see which ones I'm familiar with, which ones I've used in the past, and which ones looked a little bit arcane to me. So this is a list of the basic tools. So the first 4, I think here, should be very familiar to most people and probably use them, if not directly on a day-to-day basis, but certainly through your IDE or through your build tool, whatever it might be. After that, it gets a little bit more murky. Java H, if you've ever done any JNI programming, it's been a few years since I've done that. Java P is actually a pretty nice utility. It shows you the decompiled bytecode structure, or the decompiled structure of a class. Applet Viewer. How many of you have used Applet Viewer? Oh, wow. OK, that's more than I thought. I think there were 2 hands there. That's 2 more than I would have thought. Please tell me it's been a few years since you've used it. Six months. Wow. OK. Sounds like a session in the making. And then there's a couple of other ones here, JDEPs and Extension Check. One of them does dependency checking. I have to admit I've never used it. Sounds interesting. Maybe when I'm finished here, I'll take a look at it. Final one is JDB, which is a Java debugger, which is a command line Java debugger. I've actually used that in the past. I found it to be fairly helpful, certainly before the days of IDEs, where Java debugging became a lot easier. But that's the first group of tools that are in the JDK bin directory. All right, then we've got some security tools. So again, some of these I know I've used. Key Tool, I've used that one. Jar Signer, I think I've used that a couple of times. Policy Tool. The last 3, Kerberos, don't think I've ever touched those. And then we've got some really fun ones. We've got the Corba and IDL tools. Now, backwards compatibility is a great thing, but at some point, these have got to die. I mean, it's just time. Finally, there were a couple of groups I didn't include for schema generation, for WSDL files. Again, some of these tools I'm not even going to touch. But here are the ones that we're going to be focusing on. These are the monitoring tools. We'll take a closer look at each of these. And then in the next slide, we've got the troubleshooting tools, which are also ones that we'll take a closer look at. And it's really these last 2 slides, which are the ones that are going to be the focus of the presentation today. The last group are the native tools, which are platform dependent. Everything that we've been discussing up until this point, you should find them on every platform. Just on Windows, you've got some of the standard Windows debugging tools, and Linux, you've got some of the standard tools as well. Notice on both of these, the last entry is hprof, which is actually a Java agent. I'll mention it later on. I'm not going to discuss it in any sort of detail, but they are Java agents that you actually have to be running your Java program together with in order to be useful. Okay, so now that we've discussed, try to home in on what exactly we'll be looking at. Next topic, I want to spend a little bit of time talking about the different entry points into the JVM. Like I mentioned, I was rather surprised by the number of entry points that there are into the JVM. We'll discuss each of these, but at different tools, as we'll talk about, and I'll try to mention which of the tools match up to the different ways of connecting to the JVM. but there are different ways that these tools connect to the JVM. Now, I'm not entirely sure if there's a legacy historical reason for all these different communication points, and possibly some of them may go away in the future. But nonetheless, each of these tools has a different way of communicating with the JVM. And what that means is there are actually little, I don't know what to call them, openings, orifices in the JVM, which allow you to connect through these different mechanisms. So let's take a closer look at each of these in turn. And the first one is called the attach, or the attach API. So this is actually a standard, well-known API defined by the JDK. I believe it was introduced in Java 5. Somebody may correct me on that. Maybe older than that. But the idea was to provide a standardized way for, a standardized and transparent way for a client to attach to a local running JVM. So it's only for local attachment, only for local connection. As I mentioned, local access, and it must be by the same user. So however the particular program was started, however the JVM was started, whoever has ownership of that can only be accessed through the attach API by the same user. And I'll mention it more in detail, but here are some of the commands that utilize this attach API. And what's important about the attach API is that everything is transparent to the client. So the actual mechanics for how to attach to the JVM through the attach API are going to be platform dependent. And I'll show you that in just a minute. But to the user of the attach API, the client of the attach API, it's completely transparent. It doesn't matter how it works. It's a level of abstraction for attaching to the API. Attaching to JVM, excuse me. So, on Linux and on BSD, also on a Mac system, so the attach API will actually create a socket, and if you use the attach API, you'll actually be able to see that socket on the file system in tempdir, and it's got the prefix attach PID along with the PID as a suffix. So it'll create a socket, and it'll communicate through that socket. The attach API, the client, and the JVM will communicate through that socket, and again, completely transparent to the client. On Solaris, instead of using sockets, it'll use the door API. Now, when I say it like that, you probably think that I know exactly what the door API is. I have no idea what the door API is. I'm sure it's really cool, but that's how it communicates on Solaris. And then finally, on Windows, completely different mechanism used by the attach API. The remote process will actually inject code into the running JVM, which is really surprising to me. This guy sounds almost like bytecode interleaving at runtime. I mean, it actually will insert code. And then finally, it'll create the remote process will not only insert some code, it'll create a thread in the JVM in order to call the code that you're requesting. And finally, it reads the result via a pipe. So this is rather intrusive, but again, the good news is you don't have to know any of the details, the underlying mechanisms for how this works. All you know is that you're given a nice connection to the running JVM on the local machine. All right, so that was the attach, is the first communication entry point. Second one we'll talk about is JMX. And the truth of the matter is we're not going to be focusing so much on JMX because most of the command line utilities that we'll talk about do not utilize JMX in order to have an entry point into the JVM. JMX is actually used by a lot of the UI utilities like Visual VM or JConsole. So we'll mention it here as one of the communication entry points, but you won't see it much in the rest of the slides. It's the most common way, or I should say the most common way by the UI clients. And there are, at least in the spec, the JMX does not specify what the transport mechanism is, and that's by design. Most common way to connect is through RMI, but in theory, JMX can connect via other mechanisms as well. All right, next one. Next one is JVM stat. So the JVM stat is actually a lightweight performance monitoring for hotspot. And when you run a program, unbeknownst to you, the JVM is actually doing some monitoring on that process. Now the good news is, because this is the default, and unless you specifically turn it off with this JVM parameter right there, it's been optimized to such an extent that there is a negligible performance hit, if any. In fact, when I was reading up on this, there seemed to be some indication that turning it off would cause a performance hit, which is particularly interesting. I don't know exactly how that works, but you don't really need to worry about keeping it on. It can provide some really useful information, and the JVM continuously updates this monitoring information and will store it in a memory mapped file, which you'll be able to look at this well-known location. And like I said, the JVM is continuously updating this with the monitoring data, which are available to some of these tools. And there is a well-known entry point to connect to this JVM stat to obtain this information. One thing I will mention, there is some bad news with this, and this is spelled out in the documentation. JVM stat is not supported on Windows 98. So, time to upgrade to Windows ME. And I could not find anywhere it's spelled out about OS2, so you're on your own there. To me, that was just an example of the documentation being a little bit long in the tooth. Now JVM stat is, again, locally, shouldn't say again, but it's local. It's a local way of connecting. And again, it must be the same user account. There is a mechanism for connecting remote interface to JVM stat, and that's through another command line utility called jstack, which will run on the remote machine that you want to obtain the monitoring information. So you run this daemon on the remote machine, and then the local client, well, local and remote, it's all relative, but the machine that you are trying to connect to will connect over RMI. And you only need to start one daemon per machine, and you'll be able to connect to all the JVMs on that machine. And hopefully, if I have time, show you an example of that. All right, so that's as far as JVM stat. Next mechanism of communication is the Serviceability Agent, or SA, as it's called in the documentation. And this uses the debugger interface. The JPDA is a standard way for Java debuggers. This is what your IDE uses to connect to a running process or to allow you to debug through a process. Now the thing is here with the SA, as opposed to some of the other mechanisms, for example, the attach API is a coordinated communication between the client and between the running JVM. So there's actually a coordinated effort in that communication. When it comes to the Serviceability Agent, there's no coordination with the process, and will actually suspend the process in an unknown state. It will not be able to run, or the JVM will actually suspend and will actually not run at that time. And it's, again, the documentation states an unknown state, which means that in theory, when the Serviceability Agent detaches, it is possible that the machine will be completely hung. And so because of that, now that I've never seen that happen, but again, it's a unknown state. And because of that, this is considered a last resort, and we only utilize the Serviceability Agent in circumstances, as we'll discuss, where the process might be hung. And you want to get some monitoring and trouble information from a hung process. Now, if it's already hung anyways, you're not going to be doing any damage by connecting to it in an unknown state. But usually, we try to avoid connecting in this manner. In addition to that, we can connect to a core file through the Serviceability Agent. Through some of the APIs, that allows us, there are some hooks that the core file creates that allows us to connect, to monitor, I shouldn't say monitor, to troubleshoot and to inspect the core file after a dump. Now, just to distinguish the serviceability agent from regular debugging, if you've ever started your application in a debugger in the IDE, so you've had to put some, or if you tried to connect to it, you've had to put some command line arguments there in order to be able to connect to it. Now, the serviceability, that is the standard way of attaching a debugger. The serviceability agent is considered experimental, does not require any arguments. Again, it's this entry point into the JVM, which is a little bit more intrusive than standard debugging. But the advantage is that it does not require starting the process with command line arguments. Because, as we all know, we have a running JVM, and we've got an issue. Well, if you go tell somebody you got to start with some command line arguments, too late. Once you start it again, you've lost the state that you needed in order to debug it. So this affords us the ability not to have to run and not to have to restart it, but still be able to monitor and do some troubleshooting. And as with the JVM stat, we have an ability to connect to a remote machine and to connect through the serviceability agent. And it's a similar tool to the jstack, but it's a remote client. It connects over our RMI. Now, there is a difference here, and I don't know if this is a historical reason, but as opposed to jstack, and we'll talk a little bit more about this, but jstack, you run one daemon for all running JVMs on the machine. In this case, you have to start one daemon per process. And finally, this is the last communication entry point that we'll talk about. This is probably the newest one. It's called the Java Discovery Protocol. It was introduced fairly recently, Java 7 Update 40. There were a whole bunch of changes introduced in 7 Update 40. And basically, using the Discovery Protocol, the Java process will broadcast its presence every 5 seconds. And so any client that's inspecting or listening to this broadcast will be able to hear it. Now, in order for this to be activated at the current point, you have to start the JMX, the management agent, and you have to run the process with some command line options. If you're very interested, I put the link there for some more information. This is not something I'm going to talk a tremendous amount about because, like I mentioned, this is a fairly recent mechanism used by the JVM. And most of the utilities, most of the tools that we'll take a closer look at do not utilize this yet. It is used by the Java Mission Control if you've used that tool. I do get the impression, reading a lot of the documentation, that this is going to be something that's going to be used more and more as time goes on. So it is helpful to at least be aware of it at this point, even though I'm not going to mention it anymore in the slides. Here I've got a little diagram here. Just give you a little idea, try to summarize some of the different communication paths and local access versus remote access, coordination of communication versus non-coordination, whether they talk to core files. That little box over there was supposed to be like a half check mark. I don't know what happened. But the indication is it's not really two-way communication per se. Like I mentioned, it kind of forces its way in, and there's not a two-way direct coordination between the two processes. But again, these are just giving an idea for what the capabilities and the way in which each of them coordinates with the running JVM. And in the last column, even though we haven't introduced most of them yet, but also get an idea, it's more of a reference slide, but which of the tools utilize which of these entry points. All right. As you're taking a look at this slide, I'm just going to ask you to please try to restrain your intense feelings of jealousy for my graphic design capabilities. If you're very interested, you too can learn how to clash colors. There's a reason why I work in computers. But this is just a little diagram just to show you the different tools. Again, this is more of a reference type of slide. Different tools, how they communicate, And in the green box is one machine. This is a different machine. So we see that there's different ways that they communicate, RMI to the server where the JVM is actually running, and different entry points in the actual JVM itself. We've got the attach, we've got JVM stat, we've got the serviceability agent, and the different tools will communicate via these various communication paths. All right, any questions? Just take a little drink before we continue. All right, so at this point, let's actually take a look at the tools. And one thing, a caveat I should mention as we're going through each of these tools, I think that every single one, if you look at the documentation, every single one is still labeled experimental. I have a feeling this is kind of like when Gmail was in beta for 5 years. So I have a feeling that these tools have been experimental since the beginning of Dawn, and they'll never actually exit experimental. But I feel like I've got to share that disclaimer just so you're aware. So the first tool is JPS, which, as you can probably guess, is used for getting a list of the running processes on the local machine. So JPS will query the running JVMs on the system. So instead of having to run PS and then grep it through Java or something like that, you can easily get the list of the running JVMs on your machine. And you'll see that this is the quote from the documentation. This is the official description. Every instrumented Java hotspot VM for the current user on the target system. So again, this is the current user. And unless you're running JSTAT, this is on the local machine. It'll show you what is called the LVM ID, the local virtual machine ID, which in every single case currently is the PID. All right? But they want to disassociate it with what's actually the PID. They want to make it platform independent. So they call it the LVM ID, but in every circumstance that you'll encounter at this point, that's the PID. And there are various options to show you the full package name, arguments, and the JVM arguments. One thing to note is that if the Java Pro application has been run with a custom launcher via JNI, you will not see the class name. You only see the PID. And the most common example of that is if you start your IDE. I'll show you an example of that. So if you start IntelliJ, it won't actually show you the name, and there are various reasons for it. There are bug reports about it going back, I think, to 2004. It makes it sound like they're not going to fix that one. Also, you're going to have a hard time with Windows services. So if you've got Tomcat or if you've got something else running as a Windows service, you're going to have a tough time seeing that particular program show up in the list. And it will get a list, the way in which it gets a list, and you see, you get an indication of that from the very first quote there, is through JVM stat. Now, just as an aside, what that means is, if you've run your program with that command line parameter to turn off monitoring through JVM stat, it will not show up in this process list, since it won't know about it. All right, next. That's a fairly simple tool. Next is JSTAT. Now, JSTAT will show you the actual performance and resource consumption statistics for the monitored application, the monitored program. So that you'll see the heap sizing and the garbage collection information. And again, this will show you the information that's contained or that's monitored by the JVM and that's contained in that file that I showed you before. So there are class loader statistics, compiler statistics, garbage cluster statistics, and you could also do a sampling interval, sampling at a certain interval. When we get to the demo, I'll show you a little bit of that. JSTAT-D, as I mentioned before, allows you to do it on a separate machine, allows you to actually connect to run JSTAT on a separate machine. You do need to set up a security policy. And like I mentioned before, you run one instance for all the JVMs on the remote machine. Okay, so those two were the JVM stat. Those two utilized the JVM stat communication entry point into the JVM. Now we're going to take a look at some of the utilities that use the attach API and the serviceability agent. So the first one is jstack. jstack I found to be an extremely useful utility. It will show you the stack traces of all the threads that were running JVM or of a core file. Now, by default, if you don't run it with any options, you specify a PID, it'll connect via the attach API. And there's options for showing you information about locks, and on certain platforms, you could also see native frames. But what's especially useful that I've found is if you have a hung process, right? You can't connect to it, can't do anything with it, and you want to figure out, well, at least show me the stack trace. So if you were to run jstack without any parameters, you won't get anything back, because jstack, again, utilizing attach API, requires a certain amount of coordination between the client and the running JVM. If you run it with a -f, it will use the serviceability agent, and it will force its way into the process, and more times than not, that has saved me, because I've been able to get at least a stack trace of all the running threads, and it'll help me isolate which one is causing the hang, which one is causing that process to hang. That's a very handy utility, and especially in certain circumstances using -f. Next one I'll look at, and if you were here for the session right before this one, the presenter mentioned jmap, didn't go into it. I was a little bit concerned he was going to steal my thunder. A jmap allows you to do a couple of things. Number one, get some memory-related statistics, and number two, to actually create a heap dump, or an hprof, which you can then utilize, or you use that with some other tools. You could take a look at that heap dump, and again, if you were here for that previous session, very nice session, utilize that to try to find memory leaks or try to figure out where a lot of your classes are doing. Again, could be a very handy utility. So you could get a couple different types of statistics, heap-related information, class histogram, and also permgen statistics, at least for before JDK 8. JDK 8, the permgen has gone away. And once again, if you've got a hung process and you want to get a heap dump in order to be able to analyze that heap dump, you can attach via -f, which will not use the attach API, but will use the serviceability agent. All right, next tool, and I get the feeling JInfo is one of the oldest utilities that's provided by the JDK, but it provides some configuration information. Actually, I found this probably to be the least helpful tool, putting it in more for completeness sake. And then, like I mentioned before, the JSA debug D, I'm missing a G there in the title, is a daemon that allows you to connect using the serviceability agent to a remote machine. And so you can actually run JStack or jmap on a running JVM on a remote machine from the machine that you're at, as long as you've got JSA debug D running on that remote machine. Now you run one instance per JVM, and it'll utilize RMI, and you start each instance, best practice started with the server ID, which is actually an RMI artifact. And if we have time, when we go through the demo, I'll show you that as well. All right, so the last of the attach API tools is, I don't know how they call it at Oracle, I call it jcommand. Sounds a lot better than jcmd. And that's probably the newest of these commands. It was actually merged when Oracle purchased Sun, so they started merging the two JVMs. Oracle had JRocket and Sun had Hotspot. Hotspot seems to have become kind of the standard bearer, but they've merged a lot of the utilities that were in JRocket, and one of them is jcommand. And according to the documentation, it supersedes some of these earlier commands that we've seen, jstack and jinfo, jmap. There are some capabilities that these superseded commands contain that jcommand does not. So it's not a complete replacement. One of them is that you cannot do any remote, not directly, you can't do any remote access via jcommand. Jcommand uses the attach API, and therefore it uses its only local access. The only way that you could do a remote jcommand operation is there is an mbean. It does create a little bit of a chicken and egg issue because one of the usages of jcommand is in order to start the management agent, in order to start JMX. But it is available at least through an mbean. Now what's really nice about jcommand is that it is self-describing. So you'll look at some of the other commands and there'll be differences between JDK 7 and JDK 8, for example. Some of the command line options may be different. Jcommand is completely self-describing. So it's not, you don't have a set list of command line parameters or anything like that. Instead, you run jcommand along with the PID and then help, and the process itself responds with the supported commands. So you actually get a list of supported commands. And then in order to get a help on a specific command, jcommand, PID, help, and then the name of the command, and the process itself, again, will respond with help about that specific command. And so what's really nice about this is between JDK 7, JDK 8, and then whenever JDK 9 comes out, jcommand will look exactly the same. But what the process responds with, that will be different. And so there's no need to change the command line parameters or the options that are available. So this is just to give you some of the idea for what jcommand provides, but again, this is completely described by the process itself. There are various things you'll see here, and you'll see why in the documentation specifies that it supersedes some of these older tools. GC statistics, you start JMX, data native memory, heap dump, stack traces, JVM information, performance counter. So it's a whole list, and the idea is that as time goes on, there's a specification for in JDK 9 to add a whole host of different troubleshooting commands, monitoring commands, but the idea is to be able to easily add new commands without having to add new utilities. You just add them to the list of self-describing commands that are returned to the client. And then I think this is the last one here, is JHAT, which is the Java Heap Analysis Tool. I like this. If you take a look at the documentation, it says it could help you find unintentional object retention. Now, in the rest of the world, we call that memory leaks. But in the Oracle world, it's called unintentional object retention. And it reads the heap dump. It'll show you, now again, if you were here for the previous session, showed you some of the UI utilities for Visual VM for analyzing a heap dump. This is a little bit more primitive tool, but it's nonetheless can be very useful in tracking down memory leaks, excuse me. What it does is it actually start a web server that you can connect to and take a look at some of the class histograms, instance counts for certain classes, do a lot of the same things that you can do with some of the UI utilities, but a little bit more primitive presentation. Something that I forgot to mention at the very beginning, this is another benefit potentially to using command line utilities. You may be on a system, on a headless system, where UI utilities are not available, where the only thing you've got are command line utilities. So yeah, most of us would prefer to use UI utilities, but we don't always have that at our disposal. Sometimes the only thing we have are command line utilities. Or we can't get the, for whatever reason, we can't get the proper resources to start up JConsole. They won't open the ports or whatever it is, but the command line utilities are, in that type of environment, can be a lifesaver. All right, so I've gone through the tools. In the remaining time, depending on how long each of these different things will take, try to go through a demo to try to just show you. I won't go into any depth about any of these tools, but just to give you a feel for how you might use these tools in their application. Any questions before I do that? All right, excellent. All right, just let me take out my cheat sheet here, make sure I cover everything. So on my machine, I've got a few things running right now. Just clear the screen so that it's a little bit less distracting. I've got a Tomcat server running with Jenkins. Since I'm Scala guy now, I've got SBT running. And I've also got IntelliJ running. So when I run JPS, be the first tool running JPS, by default what you'll get is the PIDs and then the actual name of the application, which usually is the class name, but you'll see that if it's run through a jar, you'll see the name of the jar file. Now the last one there, you'll note, has nothing. That's my IDE that's running. That's IntelliJ, like I mentioned before. Because it's running through a custom launcher, does not display any name. So I'll go through this pretty quickly, but there's a couple of parameters here that I could pass. If I run jps-l, it'll show you the fully qualified class name, along with, for the jar file, to show me the full file path for that jar file. Still nothing for that last process there. Next, I will run jps-m, which shows me the command line arguments. So these are the command line arguments that are passed to each of these, to the various running processes. So one of them is actually something that's looks like it's run through IntelliJ, or run by IntelliJ, but again, that 5227, nothing running there, or nothing showing up there. JPS-V will show me the JVM arguments. And then finally here, if I could find it, yeah, you see 5227. I can finally tell if I look far enough, I'll see some references to IntelliJ. And you can mix and match these arguments. -LVM will give you all of them. So that's just to show you all the different running Java processes at the current time. And again, this utilizes the JVM stat entry point. So if you've turned off monitoring statistics, it will not show up here. All right, let's go through JStat. Again, try to go through these as quickly as we can, just to give you an idea. So JStat, if I look at this, it'll show me the various options. Actually, I've got to run JStat-options. So these are the options that I can run, show me information that's in the monitored information by the JVM. So JStat-class, let me get my Tomcat. So that's the Bootstrap is the Tomcat running process. So I'll run JStat class 1394. And what this shows me is the number of classes that it's loaded, number of bytes, number that's been unloaded. What I'm going to do now is I'm going to have it run and give me information every 10 seconds. Now what I'm going to do is I'm just going to go into, I'm just going to click on a few links, try to get it to load a few more classes. Come back here, wait for the next run. Hopefully it'll show. Yeah, so just showing you it's as as Tomcat has loaded more classes, you'll see that it's showing you the number of classes that are loaded, and that's changed over time. All right, next is to show you this. This will show you the compiler statistics, the number of classes that have been compiled by the JIT. There might be some failed classes there. So this is a little bit different as opposed to the number of loaded classes, the number of compiled classes by the JIT. Again, I'm going through this a little bit quickly, but I just want to get through as much as I can, just giving you a flavor for each of these commands. The GC option will show you, and these are, you can run the help command to see, but these are the various GC tiers to show you what's in each of them. You really have to look at the help command, but if you're a GC guru, this will really give you some helpful information. And then finally, the JStat. If I run precompilation, it'll show me the last class that was compiled by the JIT. So if I were to load some more pages, have Tomcat compile some more classes, I'd actually see this getting updated as it's loading more classes. Okay, move on to the next tool here, jstack. And once again, I'll run jstack 1394. So a lot of it's scrolled off, but this will show you, I'm just scrolling through it, this will show you every single running thread and the stack trace that each one is currently in. And then there's a -L to show me the lock information. So if there is any lock, if I've got any sort of deadlock or anything, this will show you, or it'll show you where the locks might be. See, I've got this locked ownable synchronizers. If I can find one quickly where it's actually got some useful information. Fortunately not. But if there is actually any lock contention, you'll get more information through that. I'll just show you this, -M on other platforms, not on the Mac. Nobody peek while I enter in my password. It's actually not available on Darwin on the Mac, but if you're running on a Windows machine, I think on Linux also, it'll actually show you native threads as well, which can be very useful. Just going to run the -F now. Now remember, without the -F, JStack is using the attach API. With the -F, it's using the Serviceability Agent, which will force its way in. So if I've got a hung process, that'll give me that I'll be able to get the stack trace in that way. If I can get to the beginning of this, which I want to show you what it, wow, okay. Thank you, yes. All right, yeah, that would have been a good idea. So at the very beginning, you'll note here it says debugger attached successfully. So that's how you know that it's being piped into the Serviceability Agent connection point. All right. I don't have time, but I was going to show you just how you can run it against a core file as well. If you've got a core file, then you can specify the Java executable, and you can get a stack trace on a core file. So if you've had a core dump, you can actually inspect that core dump and take a look at the stack trace at the time when the core dump was created, which can be very useful for trying to debug or troubleshoot exactly why that happened. Move quickly to jmap. So jmap-heap, was it 1394? So this will give you information about the actual heap. It'll show you, first of all, the GC, the type of GC it's using, number of threads it's using, the max heap size, current heap size, the metaspace size, which is what has replaced permgen in JDK 8. And then the actual heap usage, it'll show you the various GC statistics. So again, these are, depending on your use case, can be very useful. You can get a histogram. So the histogram here will show you the number of instances and along with the number of bytes and of the class name. So those first two are arrays of characters, arrays of bytes, and then going through. So this can be helpful, again, if you were at the previous session about finding memory leaks. This can give you a histogram of a very simple histogram of finding certain classes that may be utilizing a tremendous number of instances. And help you debug that type of situation, memory leaks. And then finally, there is, I'll just show you, there is this, you can create a heap file with -dump, and then the name of the file. I'm actually going to run it, but just specify the name of the file and the PID, and it'll create the heap dump, which you can then analyze with the tool that with whatever tool you like in order to analyze the heap dump. Now, one thing that I do just want to show you, just so you can get just to prove the point that I made, I'm running it here with the -F. Now, this happens to be one of the commands that's fairly long running. Oh. Okay, so it is, right now, it's actually iterating over the heap. Now, if I go into Tomcat, if I just try to click on a link, you notice this is not something that should be taking that long. This is because it has actually suspended the process. I wasn't lying when I said before that it actually will suspend the process, running with -F. And when I kill this, it'll be able to load because it has unsuspended it. So I just want to show you that when they say that it suspends the process, they really mean it. I want to show you jcommand, and we'll see what else we have time for, because this is probably the most interesting command. So jcommand, if you run it without any parameters, it will show you, it'll be something like JPS. It'll show you the different running Java processes. This is a little bit different than JPS. Reason being, JPS uses JVM stat to determine the running Java processes. jcommand uses the attach API, which again will be platform dependent, to determine what the running Java processes are. So it uses a slightly different algorithm to determine the running processes. But here's where it gets really interesting. So if I run jcommand and then PID, and then help, oops. So it will show you here the following commands that are available for this process. If I run a different process, especially if I run in JDK 7, I may see a different list. JDK 9 comes out, I may see a different list. I may see a different list when there's a new update within within JDK 8. But these are the commands that are available. So if I run a command, again, this is all self-describing. So if I run, for example, a very simple command, VM version help, it's actually help VM version. It'll give me information about how to run this command. So it shows me what it does, the impact, and if there are it shows me the syntax. So if there are any parameters or arguments, it'll show me all that. So this is actually one of the simplest commands. Just shows me the VM version. I'll show you some of the other commands. I won't go through all of them, obviously. But if I do this, thread.print. So this says prints all threads with stack traces. So this is very similar to jstack. In this case, it shows you the permission that's needed, and it also shows me the options that are available. I'll just run that just to show how it runs. So that's very similar to jstack. Let me see if there are any. Also, an interesting one here. I'll just show you this. GC class statistics. This shows me statistics on the classes that are loaded. This actually can be quite helpful. Let me run this quickly. So this will actually show me information about the classes that have been run, and there are various columns, which I have a little bit more time to go into it, but it'll show you various columns, and you can get information about those different columns. Again, a lot of neat stuff. Just a couple more things here. You'll notice you can start and stop the JMX management agent. You can start it locally. You could start it for remote access as well. There's one for uptime. And you can feel free to play with this on your own time. But again, the very nice thing is that this is all self-describing. One final thing with jcommand is if you run it with the PID of 0, it will show you, it will run that command for all running JVMs. So if I run it with help, it'll show me all the help that are available for every running program. And if I were to run, if I want to get the version for every running Java, I could see I've got a couple using JDK 8, something using JDK 7, and one of them it couldn't even determine. That's IntelliJ. Might be running something else. Who knows? Don't have time, unfortunately, to look at. I wanted to show you jhat, which I thought was a nice utility, but I'm just going to run it on a. I've got a. Let's do this very quickly if I can. Okay. Okay, so it actually will start a web server, and if I go to, so this is actually a heap dump I created from a program that had a memory leak, but if I go to show heap histogram, and if I sort by instance count, it'll give me, it'll show me what particular classes have got a higher than expected instance count. I can click into that, get information, look at all the instances, look at a particular instance. I can look at references, summary by type, and this can be useful again. There are more advanced tools for doing analysis on heap dumps, like Visual VM, but again, in a pinch, jhat can be very useful for just getting a very initial look at the histogram, try to determine what's going on. So let me just show you, I'll just finish off with this. Did have more, it's a shame I didn't have more time, but promised no UI, but I should just show you one thing, just because I want to show you how this information can be useful. I'm going to load up JConsole. Now, if you've loaded up JConsole, if you've never loaded JConsole, shame on you, but if you've ever loaded, you'll see there are two boxes here, local process and remote process. Local process, they actually get that list by running the same thing as running JPS. And if you click on one of these in order to connect through JConsole, it'll actually connect using the attach API. So if you enter in the remote process, it'll connect through JMX. Up here, it's using the attach API. So if nothing else, if that's something new you've learned today, wonderful. And I just have one more screenshot. Since I paid $3 for this image, I'm going to show it to you. But that means that we're finished, and I thank you very much, and I hope that you found something useful. Have a great day.